Multicellular algae do this. Each alga releases cells into the surrounding water that fuse with cells from another alga, creating second-generation compound cells. All that is required for basic sexual reproduction is organisms that are capable of releasing haploid gametes, ones that contain half the adult number of chromosomes, that can join with a gamete from another organism to form a viable zygote. THE's story of the evolution of sperm and egg begins with just such an egalitarian scenario. Parker, Baker, and Smith, 1972. Each gamete carried half the nutrients needed by the about-to-be-formed zygote. But then came variability. Some gametes carried less than their fair share of nutrients and others more. Imagine that every individual made 1,000 gametes for every milligram of material devoted to reproducing. Williams, 1996. Each gamete was worth 1 microgram, and when they fused they created a 2 microgram zygote, which made it strong enough to be viable. But now some cheating begins, thanks to the random process of mutation. Some mutants produce not 1,000 but 1,100 gametes, even though each one is slightly smaller, only 0.9 microgram. If each one fuses with a normal, non-mutant gamete, the zygote will weigh a little less, only 1.9 micrograms, but that will be compensated for by the fact that there will be 10% more of them. As long as the net disadvantage is less than 5%, the mutant form will still be ahead of the game. When two mutant gametes meet, the zygote drops to 1.8 micrograms, so now the mutant forms lose their net advantage, preventing the whole species from adopting the cheating strategy. But the situation could stabilize, favoring ever larger and smaller gametes. Organisms producing small gametes can make a larger number of them and hence a larger number of offspring, but they have the disadvantage of small size and lower viability. Organisms producing larger gametes make fewer of them, but they are better equipped and more likely to survive. Gametes have to achieve two objectives. They must find a partner and create a well-resourced, nutrient-equipped zygote. Low, 2000. Small gametes do best at the former. Sperm are cheap to make, light, and motile. Big gametes do better at the latter. Eggs carry the nourishment that the growing zygote needs to survive. Intermediate-sized gametes have neither advantage and so lose out to both. Once anisogamy, the size difference between egg and sperm, began, the gulf between them could only get bigger. Sperm that were designed to move fast and carry only the minimum fuel outcompeted slower, fatter sperm. Eggs that carried the most nutrients and conserved their energy could survive longer and create stronger zygotes, and so they became more numerous than thinner, more active eggs. So the process continued until the giant quiescent egg dwarfed the 46. Mothers matter most. Women and parental investment. Stripped down searching sperm. The consequences of this gametic cheating have been almost unimaginably far-reaching for the two sexes. The sperm will have to compete for the limited number of eggs available, and will therefore retain the locomotor mechanisms, long propulsive tails in most species, needed in the race for fertilization. The eggs can leave the work of finding a partner to the sperm. When egg producers reproduce, they must bear the entire nutritional burden of nurturing the offspring. By contrast, the sperm makers reproduce for free. A sperm is not a contribution to the next generation, it is a claim on contributions put into the egg by another individual. Males of most species make no investments in the next generation, but merely compete with one another for the opportunity to exploit investments made by females. Williams, 1996, p. 118. Thus were females rst exploited by males at a purely biological level. But the egg and sperm distinction did not end there. The greater gamete size and cost that females incurred was only the beginning of their greater lifelong commitment to infant care. It was Robert Trivers, 1972, who spelled out the key reproductive difference between the sexes. He called it parental investment and defined it as any investment by a parent in an individual offspring that increases the offspring's chance of surviving, and hence reproductive success, at the cost of the parent's ability to invest in other offspring. It is absolutely central to an evolutionary analysis of sex differences. More time and effort and individual channels into any single offspring, the fewer offspring they will ultimately produce. His simple principle amounts to a distinction between offspring quantity and quality. MacArthur and Wilson, 1967, Promislow and Harvey, 1990. Animals who have taken the quantity route are called R-selected, or fast species. Insects lay thousands of eggs but invest very little time or energy in any of them. Instead they move swiftly on to the creation of a new batch. K-selected, or slow, species, such as primates, give birth to one baby at a time and spend several years feeding and protecting it. Some animals, like cats, steer a middle course, giving birth to multiple offspring but yet providing milk and care to all of them for a limited time. The point is that there is always a trade-off. The more time devoted to one offspring, the less time to produce more. The fast-slow distinction seems to hold for men and women also. The minimum biological costs of reproduction are greater for women than for men. Each month about 20 ovarian follicles prepare their oocytes for possible ejection. One is chosen, ripened, and released into the fallopian tube. Meanwhile, the endometrium of the uterus must be engorged in preparation for the arrival of a fertilized egg, even if one fails to arrive, which, as we will see, is usually the case. Twin processes are so time-consuming and costly in terms of calories that they take about 14 days, half a menstrual cycle, to achieve. If ANISOGAMY, the start of parental inequity. 47. Pregnancy occurs, the woman's body is occupied for 9 months with gestation. After the birth, lactation requires even more calories than were necessary to sustain the pregnancy, almost double a woman's normal daily requirements, and, in the ancestral human environment, lactation would have continued for up to 4 years. For every mother, each baby represents a very large investment of time and energy, to say nothing of emotion. Compare this with a man's minimum investment. He can ejaculate several times a day. Admittedly, the number of sperm produced falls with each emission from a high of 300 million on the first occasion to a low of a mere 30 million after a 3-hour interval. Nonetheless, pregnancy only requires one sperm in the right place at the right time. Once a man has gallantly donated his sperm, any further contribution on his part is optional rather than biologically mandatory. It does not require a mathematical genius to realize that under optimal conditions a man could father half a dozen infants in a day, while a woman would take 30 years to do the same. A host of psychological differences between males and females, as we shall see, derive from the fact that women's biological parental investment is greater than men's. It is important to recall that the crucial factor that drives these sex differences is not maleness or femaleness per se, but the degree of parental investment and in some species competition for mating opportunities. See Clutton-Brock, 2007. In our species, it happens to be women who invest more heavily, but in other species like pipefishes, seahorses, and teleostfishes, it is fathers who make the greater investment. And this seems to result from the mechanics of reproduction in these species. Dawkins and Carlisle, 1976. Out of 49 species of fishes where paternal care is found, 48 reproduce by external fertilization. Trivers, 1985. Because gametes evaporate in the air, earthbound species copulate using intromission of sperm to keep them in a safe host environment. Among fishes, however, the seawater protects them from evaporation. Because of this, a female lays her eggs and they are then fertilized externally by the male. He must wait until she spawns because his sperm are lighter than her eggs and are more likely to be carried away by passing currents. Because the female finishes her part of reproduction before the male, she can then desert knowing that the male will be forced to take responsibility for the brood. Of course, the male could desert also, but there would be no selection pressures for abandoning viable offspring. A male who continued to do this would leave no progeny behind, and so deserting last is not an adaptive choice. In any case, the real bonus of external fertilization for the male is that he is certain of his paternity, and this means he can be equally certain that the effort he devotes to the egg batch is going to his own offspring, rather than a rival male's. Trivers, 1985. In humans and other mammals, however, fertilization occurs within the female's body and 48. Mothers matter most. Women and parental investment. The fertilized ovum remains there, developing, for several weeks or months. Gives the male ample time to desert, leaving the female holding the baby. Because deserting first offers the advantage of further copulations with new and unencumbered partners, it would have been selected for an, because of internal fertilization. This would lead to the evolution of a male strategy of seeking multiple sexual partners for a more complex treatment of sex role divergence. See Coco and Jenians, 2008. Because the tendency to desert is related to future reproduction prospects, desertion will be less likely among females than males because their future prospects are always lower than males. In human females, the time window of potential reproduction is especially truncated by menopause and because each infant demands such a very long period of maternal care. Why has natural selection favored this long period of parental care? After all, if infants were born ready to cope with the world by themselves, humans could produce several times the number of children that they currently do. Many mammals arrive in the world able to find their feet quite literally and, within weeks, to feed themselves. The answer is our unusual intelligence. Compared to our hominid ancestors, Homo sapiens has an extraordinarily large brain, about 3 times the size of Australopithecus McHenry, 1994. Brains are very expensive. They consume more calories than any other organ of the body. The benefits of their steadily increasing size must have been a consistent advantage at every evolutionary step. The gave us a better memory capable of storing massive amounts of information, representational thought, the ability to perform safer offline thought experiments rather than costly trial and error learning consciousness, the ability to represent ourselves in our internal model of the world language, and hence speedy information transmission, a theory of mind, the ability to accurately impute mental states to others, and metacognition, the ability to refill ECT on what we know and how we know it. A brain capable of doing these things needs to be big. It was the increasing size of the brain that posed special problems for women. Lancaster and Lancaster, 1983. Rosenberg and Trevathan, 1996. Humans were walking upright and enjoying all the benefits that came with this ability. But bipedal locomotion requires a small pelvis and, as the infant's head became bigger, a smaller pelvis meant a more difficult childbirth. Babies born any later than 9 months were simply too big to get through the pelvic bones. So 9 months became a compromised gestation period. Any longer and the baby could not be born, any shorter and the baby would be too immature to survive. But, as any woman who has given birth knows, natural selection pushed gestation time to its upper limit. During childbirth, the 4 plates that compose the baby's skull are forced over one another, leaving the newborn with a visible and vulnerable soft spot, the fontanelle. Human infants are born too early in a maturational sense. The Men and the attractions of polygyny. 49. 3 months of extrauterine life have even been called the 4th trimester. Infants are helpless, totally dependent on parental care, and have another 13 years before they reach bodily maturity. Men and the attractions of polygyny. The optimal condition for male reproductive success is access to as many fertile women as possible. If a man remains with a single woman throughout his life and is completely faithful, he can only produce as many children as his wife can give birth to. Her intensive period of investment in each child places a ceiling on his success also. But a man with 2 women can double his reproductive success. With a harem, he can increase it 100-fold. In fact, under such perfect conditions, a man's sexual performance would be even further enhanced because novelty increases sexual arousal. Coolidge FECT is named after the president's famous remark on being shown around a chicken farm. His wife, when informed that the cock copulated several times a day, asked her host to tell the president about it. When told, her husband asked if it was always the same hen. "No, Mr. President, it is a different one every time." "Tell that to my wife," he allegedly replied. Concubinage was aimed at precisely this kind of maximization of male reproductive success. Ismail the Bloodthirsty of Morocco, 1672–1727, is reputed to have had 500 concubines at any one time. They were recruited at puberty and ejected at the age of 30, and to have produced 888 children. McWhirter and McWhirter, 1975. Most men are not so fortunate, but that does not alter the basic fact that for several thousand years men's reproductive success was directly related to their number of sexual partners. Staying with one woman may have had advantages, but it had a definite cost too. Any man who took advantage of the occasional opportunity to have sex with other women had a definite reproductive edge. There is much evidence that this strategy of at least mild polygyny was and continues to be a strong theme in human evolution. Evidence comes from comparing sex differences in humans to those that are evident in other polygynous species. Polygyny is strongly associated with differences in size and strength between the sexes. Because the ratio of adult males to females is about 1:1, any male who monopolizes or impregnates more than one female leaves another male without a mate. This means that males must compete with one another to gain access to extra female partners, and this selects for ever larger and stronger males over the generations. Big males have many children, half of whom will be sons who carry their father's big genes. Small males have fewer children and so fewer sons carrying small genes. Over generations, male size increases. The size difference between human males and 50. Mothers matter most. Women and parental investment. Females was very marked indeed in our hominid ancestors. Australopithecus males were between 50 and 100% larger than females. Geary, 2000. How the magnitude of the sex difference has diminished, probably as a result of less intense male competition resulting from an increase in paternal investment and a consequent decrease in polygynous matings. It has remained relatively constant over the last 300,000 years, with males being about 20% larger than females. Geary, 1998, Hurdy, 1999. At puberty, boys' height shoots up and men's extra height is largely attributable to their longer leg length. They also develop larger skeletal muscles, and a greater capacity for carrying oxygen in the blood and neutralizing the chemical products of physical exercise. Men have about twice the upper body strength of women. Brown, 2006. They can run faster, grip harder, and jump higher than females. Tanner, 1990. In polygynous animals, puberty occurs earlier in females than in males. At reproductive maturity, a young male must enter the ferocious male-male contest for mating opportunities. The bigger he is and the greater his experience of preparatory rough and tumble contests, the greater his chance of success. So there is an advantage for males in delaying puberty, even though it means that they must wait longer for their first reproductive opportunity. In polygynous species, the female pubertal growth spurt starts earlier and peaks more quickly than in males. Lee, 1996. Is as true of humans also, and boys reach puberty at the age of about 13 to 14, approximately 2 years later than girls. Tanner, 1990. Males in polygynous species also tend to die earlier than females. Y chromosome instructs the formation of testes and so begins the production of testosterone. At adolescence, the surge in testosterone production energizes youthful sexual and competitive behavior, but at a cost. In the long term, testosterone is believed to compromise the immune system, leading to men's earlier death relative to women. Folsted and Carter, 1992, but see Roberts, Buchanan, and Evans, 2004. Logical evidence adds to the picture of ancestral human polygyny. Testes size. Harcourt, Harvey, Larson, and Short, 1981. Animals that have no need to compete for females, like the solitary harem-holding gorilla, can manage with modest testes. But animals that mate with many females must produce copious quantities of sperm to compete with other males who are also seeking mating opportunities. Admittedly, human testicles look rather undersized in comparison with promiscuous chimpanzees, but they are considerably more impressive than those of the gorilla. A final requirement of the successfully polygynous male is a strong sex drive. A male must be ready and eager to have sex at every possible opportunity, and this seems to be a marked feature of human males. Data are unequivocal. In a review of 177 data sources, Oliver and Hyde, 1993, men had a far more women as choosy investors. 51. Positive attitude toward casual sex than did women. They had intercourse more frequently, and the biggest difference of all was in incidence of masturbation, an activity enjoyed more often by men as a substitute for sex with partner. Men experience sexual fantasies and sexual arousal about once a day compared to about once a week in women, and men more often fantasize about someone with whom they have not yet had sex, while women tend to rerun past sexual encounters. Ellis and Simons, 1990. Men want sex more often than women and with more partners. They are less willing to forego sex and more willing to make sacrifices to obtain it. Baumeister, Catanese, and Voss, 2001. Because of this disparity in motivation, the frequency of intercourse for a couple depends upon the woman's rather than the man's willingness. Baumeister et al. 2001. Is as demonstrated by the very high rate of sexual contact among male but not female homosexuals where there is no female partner to gate or suppress high male sexual drive. Simons, 1979. An ingenious study in the United States documented undergraduate men's willingness to avail themselves of additional sexual partners by using a male and a female confederate to approach students on campus and invite them back to their apartment for sex. Clark and Hatfield, 1989. Predictably, 75% of men, but none of the women, took up the offer. One psychological mechanism that may give rise to this sex difference is the standards that men and women apply to casual sexual partners. Men, more than women, are willing to relax their standards very markedly for a short-term sexual partner compared to what they expect in a spouse. Kenrick, Sodala, Groth, and Trost, 1990. How men may have paired with a single long-term partner, it seems as if nature fitted them to take advantage of sexual opportunity ties whenever they arose. Women as choosy investors. Biologically speaking, men's investment is completed at conception and they are free to move on to pastures new. But women, unlike men, are quality not quantity specialists. Their investment is not limited to a few moments' pleasure, they are committed to the reproductive consequences, and women produce only a limited number of offspring. In hunter-gatherer societies, birth spacing is about 4 years and a woman typically gives birth to 4 or 5 babies in her lifetime. Each one is precious and each one must be carefully nurtured to adulthood. So great is the commitment demanded by every child that women's bodies and minds are exquisitely crafted to invest only in the highest quality child that they can produce. His fussiness is all the more remarkable since menopause drastically shortens a woman's reproductive career relative to a man's, yet still she will not invest in an infant that has a poor chance of survival. 52. Mothers matter most. Women and parental investment. First, she must ensure that her body has a reasonable chance of sustaining the pregnancy. Menstruation is the first casualty of a poorly resourced environment. Malnourishment signals that a pregnancy under current conditions would not be viable. Athletes and dancers, who put considerable physical demands on their bodies while maintaining a very restricted diet, lay down little fat and have later menarche than other girls. Angier, 1999. Although women with anorexia deliberately choose to avoid food, the body does not distinguish between an active choice and an environmental scarcity, so first ovulation and then menstruation ceases. When food is scarce before the harvest, women in Zaire lose weight and show a drop in progesterone levels and ovulation. After the harvest, their fertility returns to normal. Ellison, 1994, 1996. Same relationship between abundance and fertility can be detected by examining birth rates around the world in the wake of periods of famine or plenty. 9 months after a food shortage there is a significant drop in births. Betzig, 1997. Stress is a warning that the body is under strain. Strain may result from resource shortage in the outside environment or from problems in the immune response inside the body. Nepomnatsky, Shiner, Mastorikos, and Ark. 2007. In many cases, the two are linked. High levels of stress can suppress ovulation and menstruation because the stress response system, hypothalamic pituitary adrenal axis, is closely connected to the system that regulates reproduction, hypothalamic pituitary ovarian axis. The body shuts down the reproductive system and waits for a better time to start a pregnancy. Baker. 1996, McDonald, 1997. Acute stress, rather than chronic stress, seems more likely to trigger ovulatory shutdown. Among women who live in unrelentingly harsh environments, external stressors are consistently high and, if the body responded by shutting down ovulation, women would hardly ever reproduce. In circumstances of chronic stress, it makes sense to produce more offspring in the hope that some at least will survive the adverse environmental circumstances. Stress is relative. A woman living in more favorable circumstances may inhibit ovulation in response to acute stress. Her body, through cortisol release, signals that she should wait for a more favorable moment to conceive. Yet her current circumstances might well seem like a life of luxury to a street beggar in India. When circumstances are propitious, the time is right for possible conception. But a woman's body should be fussy about which man she will allow to take a free genetic ride on her costly parental investment. Evolution has shaped 2 ways to assist her: concealed ovulation and sperm competition. During a normal ovulatory cycle, a woman is capable of conception for only a very narrow band of time. At fertility window lasts from 5 days before ovulation to 12 hours after it, with peak fertility occurring precisely 48 hours before ovulation. The problem, of course, is that neither she nor her partner. Women as choosy investors. 53. Knows for certain when she is ovulating. It happens 14 days before her next menstruation, but, because she cannot see into the future, a woman has to rely on a retrospective estimate based on the date of her last period. Is as notoriously imprecise as cycles can vary by several days from one month to the next. The function of concealed ovulation has been a source of fascination for evolutionary thinkers. In many but by no means all primates, the female's fertile period or estrus is signaled very clearly through genital swelling. Females and males are rather indifferent to sexual opportunities outside this time and save themselves a lot of wasted energy by engaging in sexual athletics only when it will have a reproductive payoff. What is the point of concealing ovulation? There have been plenty of suggestions. Perhaps this concealment is designed to fool the woman herself. And they do indeed seem to be fooled, Even the minority of women who claim to know when they are ovulating are far from accurate. Sievert and Dubois, 2005. If ancestral women were capable of knowing when they were fertile and equally capable of observing the pain and possible death associated with childbirth, they might use abstinence as a contraceptive measure. Women who recognize their own ovulation would produce fewer children than their less sensitive peers, and there would have been selection for ignorance. Burley, 1979. But this explanation credits ancestral women with a rather sophisticated understanding of reproductive biology. It was not until the 1930s that researchers realized that ovulation occurs at mid-cycle rather than during menses as they had previously believed. Even as late as 1923, women were advised to abstain from sex during menstruation as a contraceptive measure. Thornhill and Gangestad, 2008. Although hunter-gatherers know that intercourse is connected with pregnancy, they believe that conception occurs immediately after menses. Marlowe, 2004. No wonder people have been confused. After all, most acts of intercourse do not lead to pregnancy. The latency between intercourse and the awareness of being pregnant can be lengthy, and some infertile women never become pregnant despite plenty of sex. The more obvious biological consequence of concealed ovulation is that it creates uncertainty about who the father of the child might be. And that leads directly to three very different hypotheses about its evolution based on female strategies of pair bonding, polyandry, and a blend of both. A well-advertised estrus, think of those swollen hindquarters of baboons, means that a male can copulate with a female at the right time and need only guard her against rival males for the few days of her estrus. But when estrus is cryptic and a woman is continuously receptive to sex, there is no signal to the man, or indeed the woman, of the right time. This means that repeated intercourse over at least a month is needed for a possible pregnancy, and this creates opportunity costs, the costs of all the other activities that a man must. 54. Mothers matter most. Women and parental investment. Forgo, including sex with other women. When a man makes post-copulatory investment in the woman and her offspring, as humans typically do, he must be sure that the offspring is indeed his. This entails mate guarding to ensure her fidelity and avoid cuckoldry. Continuous sex had the added bonus of holding a man's attention and cementing the pair bond. Recent research reveals that both oxytocin, a neuropeptide associated with increased trust and decreased fear, and dopamine, a neurotransmitter associated with desire and reward, are triggered simultaneously by copulation in monogamous species. Higher co-action is thought to underlie partner preference and pair bonding. Young and Wong, 2004. So, according to this scenario, women evolved concealed estrus to keep their male partners around.